think it's that time for us to get started. Hello again, everybody, and thank you for joining our webinar today. Our today's webinar is called Catch Bugs Early with Continuous Testing in the IDE. My name is Jamie Motherall, and I'm a product marketing manager and functional testing specialist here at Parasoft. And on the line with us, we have my colleague, Brian McLaughlin. Brian, did you want to say hi?
Sure. Hi, everyone. I'm Brian McLaughlin, and I'm a senior software engineer here at Parasoft for about 16 years now. I work on the unit test assistant and the test impact analysis components of JTest, which our customers use every day to build and maintain unit tests for their Java applications.
And Brian's going to be helping us out today with our presentation. Together, we have planned a great session where we're going to be discussing how Java development teams can adopt continuous testing workflows within their IDE to help them identify coding flaws and defects as they're being introduced so that they can validate code changes in real time. Now, before we dive in, we do have just some quick housekeeping. If your screen or the slides appears to be a little bit blurry, please be sure to adjust the video resolution in your GoToWebinar window in your browser. And it also helps to maximize the presentation to full screen. We highly recommend going full screen, especially when we get to the technical demonstration part of today's presentation. Now, if you do have any questions, you have any issues at all, feel free to pop them into the Q&A area at any point. One of our colleagues on the line will reach out to try to assist you if you are having any issues with GoToWebinar itself. All right, lots to cover today. We're going to start with a discussion around the need for proactive bug prevention, and we're going to break down the heightened risks associated with changed or modified code. From there, we'll dig into what we mean by IDE-based continuous testing workflows as we define and introduce live unit testing and live static analysis. We'll then have a technical demonstration on what these workflows look like in the IDE, and we'll also show how developers can rapidly update unit tests that were impacted by code changes, and how AI can also be leveraged to help you to remediate static analysis findings. We will finish off by recapping the benefits of the approach, and then we'll wrap it up and dive into our live Q&A session. Now, keep in mind, today's presentation is high level. The solutions we are focused on, Parasoft JTest, it has a lot of capabilities, such as unit test suite generation, auto mocking and stubbing, compliance testing, and reporting, just to name a few. At the end of the presentation, we'll go over some resources we recommend to help you further explore JTest capabilities. And of course, we do offer a free trial of Parasoft JTest. So after the presentation, if you just want to get your hands on it, you want to try out live unit testing and live static analysis for yourself, see how it'll impact your ability to validate code changes early, then I would say go ahead, download and get started with our trial. And then all the resources we'll discuss today, as well as the link to the trial sign up and a recording of today's presentation, will also be emailed over to you as a follow-up. All right, so let's dive in and start our discussion with the need for proactive bug prevention. Now, you probably have seen this chart at some point in your software career. As we know from Capers-Jones research, the later a defect is found, the more there is cost when it comes to remediation. And this is really due to the detective work, staff resources, engineering hours needed to understand the defect, locate it within the tech stack, and properly fix the root cause of the issue. This detective work really impacts developer productivity as less time is allocated to new code development. Additionally, fixing defects later in the development cycle causes considerable disruption to developer workflows. So productivity drops because of context switching and debugging taking up more time because that impacted code really isn't fresh in the developer's mind. So, crunch time becomes much more common right before releases because features and fixes are being mixed together at the last minute with a looming deadline. So as you're making those changes in crunch line, it becomes more of a likelihood of introducing defects. Now, early code validation, such as static analysis and unit testing, really are what enable developers to identify issues before they become costly problems downstream. And it reduces the instances of developer disruption. But really, all of this is new. This is all stuff that most people are very familiar with. People understand that code level testing helps productivity, it reduces remediation costs. So, this is not a new concept, and a lot of development teams are already doing this. However, today's presentation, we want to focus on an area that presents a higher level of risk when it comes to introducing new bugs, and that's going to be code changes. While it might be a best practice to ensure unit tests are written for new code and that static analysis scans are routinely conducted, still about 70 to 80% on average across the industry, you'll see that defects originate in changed code, meaning that code presents a higher level of risk for many organizations. Even very minor code changes can have a big ripple effect on other parts of the application, leading to unintended behaviors or conflicts that really weren't initially apparent. So, Brian, could you break this down in a little bit more detail for us as to why code changes present a higher level of risk?
Sure. So there's multiple reasons for this. One is that modern applications are growing more complex every day, and even minor changes can impact many different parts of the application in unexpected ways. So it can be difficult to test every possible scenario that might be affected by a code change, especially if there's coverage gaps in your test suites. And then as features are developed and added to the application, it becomes more mature and more complex over time. Those challenges are going to become even more prominent, right? There's also just the reality of developers being human, right? Some of us are more or less experienced as developers or with the application code, best practices and tools, or honestly, we just make mistakes.
Mhm.
And when you add things like time constraints, that can really accelerate that, especially if it means shortcutting your normal testing policies.
Exactly. With this understanding that code changes presents this higher level of risk for software bugs, development teams should put a heightened focus on validating code changes earlier in their development cycles. But that's really easier said than done in most situations. For instance, one might just argue developers should get in the habit of executing their test cases and running code scans whenever they make a code change. Even if it's a small change, run those tests locally, run that scan locally. But there are a number of factors that make this really difficult to achieve, especially with the rapid pace of development and release schedules today. Brian, you want to break this into more detail for us as well?
Yeah, so especially when there's approaching deadlines, developers are often focused on delivering features quickly, right?
Mhm.
So running a full code scan or a full unit test suite can be time consuming, especially with a large code base. There's thousands of test cases, right? Plus, there just isn't time to correlate individual code changes to individual impacted tests. And there's not time to execute that entire test suite anyway for a small change, right? So it takes time to figure out which tests to run, and it takes time to run them. So that step often gets shortcut, and you end up running only a few tests that you know about instead of a comprehensive and accurate set of impacted tests. Then there's the issue of context switching. If you're constantly switching between editing code and running tests, switching between those two things can also cost you valuable time. So those sorts of quality checks are often deferred to later in the workflow. Often even the CI or nightly jobs end up taking care of it. And then again, some developers may not be as familiar with the best practices or the tools that are being used to run those checks, or they might just forget to do it. Um, I've also seen cases where sometimes the change is just very straightforward and it doesn't look like it's likely to introduce any defects. So we leave it up to the CI/CD jobs or the nightly jobs to catch any issues. And you could be right about that most of the time, but then occasionally things get missed and then you have to go back and fix it later.
Hmm. And by not validating these code changes as code is being modified, the development team often experiences a lot of negative repercussions. So let's explore some of the risks that stem from not performing code checks or enough code checks. It can lead to build and regression failures that impact the entire development team. There's a higher risk for introducing new bugs, which in turn can result in delayed release cycles as new code development is disrupted by that detective work that's needed to remediate these issues. And then all of this impacts developer productivity, all the context switching, all of that. And that then in turn impacts the quality of the application. So let's talk about solutions next and why continuous automated testing workflows really belong in the IDE.
Yeah, so let's look at our options then in terms of when is the best time to perform checks like static analysis or running unit tests. The earliest opportunity to do that is really inside my IDE, right? As I'm modifying code and before I'm committing any changes. So ideally, I would run everything at that time, but this requires the tests and the analysis process to run pretty fast. And we already talked about how there's time constraints preventing us from doing that. So if I wanted to run tests at that time, they would have to be pretty fast, right? One thing that we've seen is that some teams will even build a commit suite for that purpose. The problem with that is that the commit suite doesn't necessarily know which tests are related to my code changes, and it couldn't detect seemingly unrelated regressions, right? And it doesn't help us with the static analysis part of that. So the next opportunity to run those checks is after I've committed my code, right? The CI/CD jobs can run all my unit tests and all my static analysis. And that'll ensure that those checks are run even if I forget, for instance, to run them before I commit my code. Now, those jobs often run more tests than something like a commit suite. But in order to get quick feedback from the CI/CD run, the complete test suite or whatever they do run still needs to run fairly quickly. That can be quite challenging though, if you have a lot of functionality. The subset of tests to run and the static analysis scope needs to be very carefully chosen and often just doesn't fit into that time frame. For example, here at Parasoft, we had a project where we separated out the slowest tests into a separate job so that our CI job would run faster, but it still took 5 hours to run, and that was in addition to the nightly test run. Now, you could argue that you should prune your test suite to keep the test run quick, but for me, this decreases my confidence that the correct checks are being run in the CI job. So to ensure that all of the checks get run and truly detect any potential regression, we could keep that separate CI/CD job, but we also still need a full nightly test run. So let me ask a question using that workflow. If I were to make a code change that caused a regression or a code violation, at what point in that workflow does it alert me to the issue? At what point does the failure show up? Now, even though we ran the commit suite and it passed, and the CI/CD job ran and everything passed, we might not see that test failure until the nightly test run. So the question is, can we do better? And the answer is, obviously yes. That's why we're here. This is really what live unit testing and live static analysis are for. Because what we can do with those is we can push those processes, those checks all the way to the left, to the very moment when code changes are still being made inside the IDE.
Mhm. So, Brian, I remember you saying that tests and analysis take a while to identify and run in the IDE. How does continuous testing in the IDE really kind of address this challenge?
Okay, so the goal of continuous testing in the IDE is to enable teams to validate their modified code automatically, right, as changes are being made without the developer having to identify or run those checks manually. And the idea there is you're going to minimize developer disruption by finding those issues before code check-in, right?
Mhm.
That's to reduce the likelihood of issues being found afterwards. So it does this by providing real-time feedback on the impact of code modifications directly in the IDE. So developers are no longer going to need to wait for their nightly or CI/CD runs to complete to validate their code changes. And by doing it in the IDE, that's the fastest possible way to get quality feedback on your changes. And of course, by addressing issues before you commit code, that's going to avoid the higher cost of fixing those issues later on in the development workflow.
All right. So really with live unit testing and live static analysis, we can now use these continuous testing workflows that are triggered automatically and they run in the background of the IDE. Now that automatic part happens pretty fast. So we're about to dive into our technical demo, but before we do, Brian, let's slow it down. Let's walk through this workflow to get a better idea of how these features work and would be used in practice.
Yeah, so first thing that's going to happen is as a developer, I'm making changes to my code, right? So I'm actively making changes. And at some point, I'm going to save those changes. Now, at the moment that I save those changes to the application code, JTest is going to identify in the background the impacted files and the individual test cases in real time. Those impacted tests are then automatically going to launch in the background. Simultaneously, a static analysis scan is also being conducted in the background on the code that changed. Now, once those background checks are complete, the status of those tests, their pass-fail status, and any static analysis rule violations are going to be shown directly in your IDE. And all of those results are going to stay available as the developer continues to work, and they're going to be updated as more changes are made. So you'll always be able to see if any tests are failing or if any possible coding issues were introduced during the change process. Now, with that information, us developers, whenever we're ready for it, can then go in and look at those results and decide how to act on whatever issues are found. So you can either update the application code to fix those real issues that the test or the code analysis found, or you can update the tests, for instance, if they're failing with quick fix actions to quickly fix failing tests or static analysis violations. And that cycle will continue as live unit testing and static analysis detects each change and updates the impacted tests list, the test statuses, and the analysis results as you're fixing things or as you're making more changes. Now, by the way, coverage is also going to be updated as the tests run. So that'll help highlight the need for new tests if you need to, or to see which of your modified code is already being covered. And once all of your tests are looking good, once everything's passing in green and all of your static analysis findings are remediated and your code changes are all done, now you can be more confident that the changes that you've made aren't creating more downstream work for you and your team.
And another benefit to this entire workflow is because these tests take time to run and static analysis scans take time to run, these runs with this workflow are happening in the background while the developer is writing code. So the time it takes to run this analysis, it doesn't actually add on to development time. It's concurrent with the development time. So developers can do all of this and save that time. So at this point, let's switch on over to the demonstration. You ready to dive in, Brian?
Sure. So just a quick, what we're going to see. What I'm going to show you is what it looks like when I make some code changes to an application. We're going to see how live unit testing and live static analysis does their job and shows me some results. And then we're going to look at how to address those results when it finds issues, how to update test cases, for instance, and how to remediate any static analysis findings.
Perfect. All right, I'm going to switch you on over to presenter, so you should be able to share screen. As a quick reminder to everyone on the line, as he's getting ready to share his screen and his IDE view, this is a perfect time if you're not already in full screen mode to switch on over to full screen. We're going to turn off our cameras here, so we're not distracting from the technical demo.
Okay, so hopefully you can see my screen. So I'll be using Parasoft JTest in Eclipse today. This also we could be using IntelliJ. We do have plugins for both IDEs, in case you were wondering. But I wanted to show you a little bit about what the user interface looks like here. So you'll notice that with the plugin, I have a JTest perspective that's going to provide a couple of specific views for us. Things like impacted unit tests, the findings view, findings details, and there's some other views here that come with the perspective that are going to be useful. What you're going to see is that as we make changes to the application, you'll see these views populate in real time. Currently, there's no local changes, so there's no results to see. But like I said, they'll populate as we go. Now, JTest uses source control to detect specific changes. For the application that I'm using here, this is a Parasoft demo application, which is a real Spring Boot application that I have checked out from our GitHub. So this is in Git. Now in the project, I have this role service object. So this is a service object in Spring that manages user roles in the application. This object already has some tests. So if I look at the test for it, for instance, you'll see, I think there's a total of 6 tests in it here that validate various use cases. So let's go to my application code and let's make a change. Let's say that there might be a case where, let's grab the normal role. And let's say that I decide that if you try and add the normal role, then we're not going to allow that. So let's throw a runtime exception if you try and add that. So this is a fairly simple change to my application just to illustrate what I want to show. And I haven't saved that change yet because as I save this change, I want you to keep an eye on the impacted unit tests view and the findings view because these are going to populate pretty quickly. So I'm going to save that. JTest immediately notices that there's a couple of impacted tests, and it happened a little fast, but you can see that it actually ran both of those tests. Also note that it only ran 2 of the tests, not all 6. It just ran the tests that were actually affected by my changes. You can also see that one of my tests is passing and the other one is not. So if I wanted to see why this one's failing, I can click on it and I can see in the findings view, there's my runtime exception that's now being thrown. And I can even look at the stack trace if I'm interested. I can jump to the test, for instance, and I can jump through the stack trace as well. So I have some basic tools here to keep track of that. Additionally, static analysis also ran in the background, and it found this violation. And you can see that it's also here in the findings view. It's also highlighted in the code. So if I was looking at the code, you can see that it's highlighted here as well. Now I can do various things with this violation. I can right click on it, for instance. I can look at the documentation to understand what this violation means if I'm not familiar with it. I can do other things like I can just suppress it in the code if I know that it's expected. And there's various other things I can do as well. What I want to do though is I want to focus on how to actually use these findings to fix these issues, because what I've done is made an intentional change here. So let's say that what I actually want to do is focus on the test first and then figure out what I should be doing with this test. So I have a failing test. If I go and I look at it, what I can see here is that what the test is doing is it's trying to add that role. Remember the one that I said shouldn't be allowed? It's trying to add a new role that it expects to be accepted. So it's up to me at this point to decide whether I want to keep this test as it is and keep its original purpose, or if I want to repurpose it to actually validate this flow through the code. So let's say that for now, I want to keep this scenario and continue to have it test the use case where it's adding a role that is allowed. So one thing I can do as I'm focused on this test is I can go and run it with the unit test assistant. Now this is going to collect a little bit more detail as it's running. And so you can see now that I have coverage data, I have some more information here about the test, but what I also get is a recommendation because JTest was able to analyze that test flow and give me some suggestions for ways to fix the test. One thing I could do, for instance, because this is an exception thrown, is I could actually update my test so that it just expects that exception. But here, let's actually just update the test with new behavior. So one thing that I can do is I can leverage my, my AI connection. So here I have a connection to an LLM-based AI, and I can actually ask AI to fix the test for me. So let's do that really quick. And what that's going to do is that's going to ask OpenAI to explain why the test is failing, to give me a proposed updated test, and then also to explain what it's going to change. So I can read this. I can look at the specific change that it wants to make. See, I can see that it knows that I should just update the specific role that I'm adding. So let's say that I review that and I like that. I can now apply that fix automatically, and I get a preview for exactly what code changes that's going to make to my test. So actually OpenAI wanted to do a little bit more here than I want. Let's ignore that part of it and only apply the change here. So I have the opportunity to make some minor edits here before I actually apply it. And once I do, let's watch the impacted unit tests, because you'll see that this will automatically rerun those tests as well because I'm making changes to the test. So let's hit apply. You see it rerunning, and now the test passed. So that's a pretty easy way to be able to go out there and update my tests in a pretty automatic way. And there's a lot of other tools, as we mentioned in JTest, that allow you to do those sorts of things. But I think the next thing to look at is how to address things like static analysis violations. So in a very similar way, I have this static analysis violation. I can right-click on that violation, and once again, I can use AI to explain to me what this violation means, diagnose the problem, propose a updated code, and even explain what it's going to do. And similar to before, I can automatically apply a fix if I like it. So in this case, what it would do is it would create a new checked exception and throw that checked exception instead, right? So as you can see, there's a number of tools there that are available to address that. I can also, for instance, suppress it in the code if I just want to keep my runtime exception. So, yep. So as you can see, editing the code normally, making those changes, I can look for failing tests whenever I'm ready. I can look at the static analysis violations. I can use those quick fixes to remediate those issues. And once everything's addressed, then I can submit my code for review with a lot more confidence, because I know that my changes won't trigger additional code violations or break any more tests. So that's everything in the demo. Jamie, let me go ahead and hand it back to you.
All right. Thank you, Brian. It's a great demonstration. Let me go back to sharing my screen real quick, and we'll get on over to our recap of benefits. So first off, thank you again for walking us through those workflows. We got to see how live unit testing and live static analysis works, how it can be used to improve both the application source code and the testing suite. And you also got to see a couple of our, well, at least one of our AI features there. That's pretty nifty. So quick sum up, and then we'll dive into a review of some resources to help you explore further, and then into our Q&A. Now, again, the goal for live unit testing and live static analysis is really to help developers identify and remediate issues earlier in the development lifecycle, focusing again on the modified code, which has that higher level of risk when it comes to introducing new defects. By validating these code changes during active development with these autonomous workflows, teams can catch defects in their earliest stages. It reduces the number of late stage defects or defects and issues that developers that can encounter that are going to disrupt their workflows. Catching these issues early on means you have fewer build and regression failures as the modified code is already validated before it's checked into source control. And it reduces the likelihood of defects, build failures, and regression failures. By reducing that defect, the developers are not really interrupted with remediation work as often. They're not context switching as much. They can focus on their main task of code development, which actually does improve the overall developer experience as well. And all of this has that large impact on reducing costs, as we saw with that Caper-Jones graph that we started off with. Finding these issues earlier, fixing these issues earlier reduces the cost of remediation. And finally, by reducing the disruption to developers and the development workflow, you get to be more productive. You have more time to focus on new code development, easier to reach your deadlines when it comes down to release. So before we end, some additional information for you guys. Now, this case study I wanted to share with you, it does not include any information on the live unit testing because we just released that, but this is a great case study to understand a little bit more what the impact of Parasoft J-Test can do for you. So this comes from one of our customers in the financial services industry. Using J-Test, they were able to boost their overall developer productivity and streamline their unit testing practice to reach their code coverage goals. They were able to accelerate their unit testing by 100%, meaning they were able to reduce the time they were spending writing unit tests by half, increasing their overall productivity. They were also able to hit their coverage numbers pretty quickly. They went from 20% coverage all the way up to 85% coverage. And they were using Parasoft J-Test test impact analysis as well to be able to reduce regression test execution times by 90%. So this got them much faster feedback, but now this release with our new live unit testing capabilities, this is going to actually accelerate them even more. I know these customers are pretty excited for this. Now that QR code, it goes to that full case study, so you can give it a review if you'd like. Again, we are going to send this on over to you in a follow-up email as well. Now, a couple more things to just go over, but quick reminder, if you haven't yet put your questions into the Q&A box, now is the time to do so. I do see we've got a couple questions in there already. So today we focused again on live unit testing and live static analysis, but we're just scratching the tip of the iceberg as far as what J-Test can do. It's a very robust tool with a lot of really cool capabilities in it. You did get to see a little bit of our AI capabilities today, but if you'd like to see more, I recommend this on-demand webinar where you can see our AI enhanced static analysis, our unit test generation capabilities as well. We'll dive into a little bit of code coverage discussion. So that's a great webinar to just take another peek, closer dive into J-Test. We also have our product tour where you can explore the IDE as well and dive into its capabilities, navigate through different workflows that might align to what your specific testing needs are. Now, if you'd like to see a demo that's more customized to your specific testing needs, say, you've got a certain coverage number you're trying to hit, you can go ahead, reach on out to us at parasoft.com, request a demo, select J-Test, and you will then get contacted by one of our account team members who will gather a little bit of information from you about what your testing requirements are, and then they'll customize a demo specifically for your teams and your project's needs. Again, we also offer that 14-day free trial. So if you would rather just grab J-Test, get up there and running, start feeling out how it's going to impact your productivity and your unit testing and static analysis practices, helping you to reduce bugs, then go ahead and download it, get started today. Our teams are here to help support you if you do have any questions or need any assistance. Um, that's it for today's presentation. So I want to thank everybody. And now let's dive straight into these questions. Give me a minute just to take a little peek in here. All right. So the first question I see, Brian, is does live unit testing only work on Parasoft generated test cases? This is a good question. Glad they asked.
Yeah. So I hear this one a lot. So the answer is no, it doesn't just work on the Parasoft stuff.
Mhm.
The test impact analysis, live unit testing, and all the other features that we've seen today, they work with any JUnit test. So there's no special libraries, there's no annotations or anything like that. It'll work with pre-existing tests and legacy projects. In general, even if you do generate tests with JTest, the tests are written in a way where they look very much like they were written by a developer, right? They're normal JUnit tests. They read like normal JUnit tests, and so yeah, everything is compatible with normal stuff that you would see on a day-to-day basis.
Okay, this one, it looks like they want us to dig a little deeper. So you ready to be challenged?
Okay, sure.
How does JTest know which tests are impacted? So they want to get
Um,
behind the
Good
scenes,
technical
learn a little
question.
bit about the JTest brain.
Yeah. So JTest has a couple of ways to do this. One of the main things that it uses is the code coverage that's gathered while tests are being run. It can use code coverage to map individual tests to the modified lines in your code. The IDE keeps track of, because it has its own source control integration, so it knows about the specific code modifications that you've made. And if you correlate that with code coverage from the tests, we can use that to pinpoint the precise tests that are impacted by code changes. But there's also another way we can do it, because even if you don't have code coverage, we also have heuristics, naming conventions, those sorts of things that we can use to intelligently locate those tests. And even without code coverage, it's pretty good. It's pretty accurate.
One thing I want to add here is this ability for us to leverage code coverage to identify which test cases have been impacted by change. If your application is written in Java or .NET, this is actually a capability that we have to support even functional testing. So we can gather the coverage from your functional test cases and then use what we call test impact analysis to actually correlate those code modifications to your test suite using that coverage data. So you're running maybe large test suites that are web UI end-to-end tests, API tests. Some of those tests can take a long time to execute, especially depending on the complexity of the tests. So this can really help teams to get faster feedback altogether, increase their, accelerate their testing cycles. All right. What LLMs do you integrate with? That seems to have caught someone's interest there.
Yeah, so in general, we support LLM providers that are compatible with OpenAPI's REST API. So that'll include things like Azure OpenAPI, GPT, Gemini, but you can also do custom OpenAI endpoints. So for instance, if your organization is using your own model that maybe you've cultivated internally, things like that, we can connect to those as long as it's compatible with the OpenAPI standard. And a common corollary that I hear, I know I'm kind of adding a question and answer onto this, but a common corollary that I also hear is what kind of data do we send to that LLM? And the answer to that is, it does depend on exactly what you're doing. But for instance, what we were looking at today, if you're wanting to fix a test with our AI integration, the only things that we're sending are things like the actual test that failed, the failure message, a little bit of the stack trace. That's basically it. So minimum information, with some basic context to give LLM just enough to be able to give you a fix. And of course, that's sent over a secure connection and all that kind of stuff. So yeah.
All right, and then this looks like a pretty good one. Sometimes I commit code and want to come back later to it. Can I use this based on Git history? That's a good one.
Yeah, so that's kind of an advanced topic, but yes, JTest does have an advanced feature that can identify code based on your Git history. So, for instance, if you use workflows like pull requests, or if you're using feature branches and you want to be able to run impacted tests for everything in a feature branch or on a pull request that's already been committed, there is configurability there to allow JTest to use your Git history to map the impacted tests to modifications in an entire Git history. So yeah, it's an advanced thing, but yeah, you can do it.
And I think we've got time for just one more question here. And I like this question. This is on our static analysis. So I see we're using recommended rules. What kind of static analysis rules are there, and can I customize them? Do you want to take that, or do you want me to, Brian?
I think I'll let you take that one.
All right.
Okay.
So as far as recommended rules, you get to select what test configuration is what you want to designate as your recommended rule set. Now, JTest ships with, I believe it's over 2,000 rules at this point as far as individual checkers. And then they're divided into out-of-the-box test configurations. So for instance, if you want to align to OWASP, CWE, Cert for Java, things like that, that's all supported out of the box with Parasoft JTest. We also do a lot of rule sets that are designed to enforce best Java coding practices. And our static analysis, all of our rules are kind of split into three different categories. So pattern-based rules, which are more preventative and more following best practices for coding. Then you get to data flow analysis, which is really going to be more of like your security checks. That typically is going to require you to run those static analysis checkers against your entire source code. And then as well as metric-based analysis, which is really looking at the cyclomatic complexity of the code under test. So when it comes down to the recommended rules that you would run in your IDE as a part of the live static analysis workflow, we would recommend that you more focus on pattern-based rules, metric-based rules, so the ones that are going to be more about best practices, preventing the introduction of new issues, new defects. The ones that are deep data flow, again, you're going to want to more save those for your CI/CD process. That'll require the deep data flow analysis will require the full stack trace.
And just one little detail that I might add to that, when I was showing live static analysis, I was using recommended rules that are built in. You can set whatever rule set you want. So, you know, as you were saying, you can build your own rule sets, decide which ones you want to run, and then tell live static analysis that you want it to run your own rule set, and you can share it across the team and things like that. So there's a lot of that kind of configurability and customization too.
Exactly. All right. Well, thank you, everybody. That's all the time we have today for questions. If you do have any lingering questions, feel free to reach on out to us. We're always happy to chit chat about testing and assist you in any way that we can. Feel free to follow us also on LinkedIn. You'll see that we'll post information there about new webinars coming up, new presentations, and our releases, of course. Everyone, again, thank you for your time today. Have a great day. Brian, you want to say anything before we end?
No, just, you know, it's great to be able to do this sort of stuff, and it's great to be able to talk to people and show just amazing technology. I love it.
Perfect. All right. Thank you, everybody. You have a great rest of your week. And if you're US based, have a very nice Thanksgiving coming up next week. Bye-bye.